Amazing work, fourth grade. Congratulations on making it through another week of online learning. It is Friday, woo, which means we just have one more quick review before the weekend. If you have not completed any of your assignments on Monday, Tuesday, Wednesday, or the quiz yesterday on Thursday, please, 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 please do so by Sunday. If by Monday morning none of those assignments are complete, or maybe you're missing one or two, unfortunately, you'll receive a score of 0 on those assignments, and that will significantly lower your grade. So please, please, please try and take the time to complete all of those assignments. And if you're confused on any of the assignments, rewatch the videos or visit office hours with Ms. Hernandez or Ms. Rowe. Okay, for today's review, we're actually going to continue to talk about equivalence. I noticed on yesterday's quiz, we were a little confused on the last two questions, number 11 and 12, on how we add hundredths and tenths together. So we're going to start off with a story problem. Make sure you have your pen, paper, and pencil, or whatever it is that you need, ready to go and labeled. Let's go ahead and read the first question together. Jamal has 5 cents in his pocket and 5 cents in his wallet. What fraction of a dollar does Jamal have? Go ahead and read the story problem to yourself. Okay, now that you've taken the time to read the story problem to yourself, let's make some annotations about the story problem. We know that Jamal has money in his pocket and he has some money in his wallet. He has 5 cents in his pocket and 5 cents in his wallet. And we want to know what fraction of a dollar does Jamal have. So the annotations that we should make are all of the important details, which includes the money that's in his wallet and the money that's in his pocket. And then what the question's asking. The question is specifically asking for a fraction. So what fraction of a dollar does Jamal have? And this is really, really important. It's not how much money does Jamal have, it's what is the fraction of a dollar. Now, let's talk a little bit more about fractions, or more specifically, what we know about fractions. Fractions are numbers. That's right, numbers. And they're numbers that usually have a value of less than 1 whole. However, there are fractions that we have seen throughout the school year, such as improper fractions and mixed numbers that show values that are greater than 1 whole. But when you take a look at the amount of money that's in Jamal's wallet and Jamal's pocket, does he have more than $1? You're right. He has less than $1. So since he has less than $1, our fraction is going to represent the value that is less than 1 whole dollar. That's right, less than 1 whole dollar. So again, we need to find a fraction. The other thing that we know about fractions is that fractions express numbers that are in equal groups, that's right, equal groups. Well, the one fraction that we all know so well is 1/2. Well, 1/2 is when you take 1 whole of something, 1 whole sandwich, 1 whole pie, 1 whole pizza, and you cut it into 2 equal sized pieces. Well, what that means is that we can also separate things into equal sized pieces, and it doesn't have to be just food. It could be things like money. And we know that things like money can represent fractions because we can make change for $1. And we know that change for $1 means quarters, dimes, nickels, or pennies. So because of that, I have actually, dun dun dun, I've counted all of these pennies beforehand, and I promise you there are 100 pennies here. Why would I want 100 pennies? Because 100 pennies is equivalent to one whole dollar. And as you can see, actually you don't see all of my pennies. There we go. And each of these are in stacks of 5. They are in stacks of, that's right, 5. I thought it would be way too tricky to have to line up all of these pennies. So they're in stacks of 5. Well, if I were to represent what's in his wallet, well, here is 1, 2, 3, 4, 5 cents that's in Jamal's wallet. Here's also 1, 2, 3, 4, 5 cents that's in his pocket. Well, that means all together, Jamal has, that's right, 10 cents. That's all he has. Well, does he have an entire dollar? No. So one way that we can express how much money Jamal has is that he has 10 cents out of 100 cents. So we can represent that as a fraction to show the 10 pennies that Jamal has out of all of the pennies Jamal needs to make, that's right, one whole dollar. So here's one way to represent how much money Jamal has. Now I want to go ahead and show you a different way. We talked a lot this week about decimal equivalence. And equivalence means the same size. It means that's right, same size. This is really important because this answers your question at the bottom. Again, fractions are equivalent because they are the same size. Well, if I have 10 pennies here, I can also collectively count them as a group. So what that means is, if I bring them back to their groups of 5, we can say that we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Well, 20 groups of 5. But since the question is asking what fraction of a whole dollar does Jamal have altogether, we're making the consideration for what's in his pocket and for what's in his wallet. So that makes a group of 10. So if I put all of the pennies into equal size groups, and these are in groups of 10, we can then represent the amount of money that Jamal has now based off of in groups of 10. So this is what Jamal has in his pocket, and this is how many groups there are altogether. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what that means is that Jamal has 1 out of 10 equal size groups of 10. So another way to represent that value is 1/10. They are equivalent. They are, that's right, equivalent. So now let's go ahead and look back in our answer choice to find either 10 100ths or 1/10. Looks like that's choice B. Choice B shows 1/10. Don't get tricked on letter D, which shows 1/100th. That would be 1 penny out of 100 pennies to make one whole dollar. And we know Jamal has 10 cents altogether. We're going to continue to use this idea of equivalence to help us answer questions 2 and questions 3. Go ahead and organize your scratch piece of paper. Okay, go ahead and read question number 2 to yourself, and then I'll read it aloud. Make any annotations on your scrap piece of paper. Question number 2 says, what is the solution to the expression below? 20/100ths plus 3/10ths. Our answer choices are in expressions of hundredths and tenths. Let's go ahead and continue the idea of what we used in the first example with Jamal and the money to help us answer this question. Okay, when we look at this expression, we notice that the denominators are different. Does that mean they are the same size? No. In order for us to be able to add these fractions, the denominators need to be the same. They need to be that's right, the same. We cannot just add these and then choose a denominator. So in yesterday's quiz, I saw that a lot of scholars added these amounts together, the numerators, and then chose a denominator. Unfortunately, that is not how fractions work. These fractions have to be the same size. So if I were to take 3 groups of 10, 1, 2, 3, and then if I were to take 20 pennies, because I know that all of the pennies together would be 100 pennies, 10, 20. I can now count the amount of pennies we have all together. These pennies are still in stacks of 10. 10, 20, 30, 40, 50. Let's go ahead and count it again and make sure that we didn't get tricked the first time. 10, 20, 30, 40, 50. Well, that must mean then that 20/100ths plus 3/10ths is equivalent to 50/100ths. Because 3 groups of 10 make 30. 10, 20, 30. That tells us that 3/10ths is equivalent to 30/100ths. And 20/100ths plus 30/100ths is equal to 50/100ths. Let's go ahead and select that as our answer choice. Looks like that is choice letter C. I want to go ahead and give you 1 minute to solve question number 3 on your own. Use all of the examples from questions 1 and 2 to help you. And if you happen to have any money at home or anything that you can count that'll help you answer these questions, please use it as a resource. Go ahead and go to work.
Okay, guys, let's go ahead and review that last question together. Hopefully you were able to get most of the work done. If we continue to review what it is that we're talking about, which is that we cannot add fractions unless they have the same denominator, that's right, same denominator, we need to make an equivalent fraction. 7/10 is equivalent to 70/100, so we can now add 30/100 with 70/100. All together, that equals 100/100. Let's go ahead and find 100/100 as our answer. Last but not least, don't forget that just after this last question, you're going to be asked why are fractions equivalent. They are equivalent because they are the same size. So please make sure you have that in that last question. All right, question number 3, our answer is 100/100, and that is B. Amazing work, friends. Go ahead and click next here at the bottom, finish your independent practice, then go ahead and complete any work that you haven't done throughout the week. Have an amazing weekend. I'll see you on Monday next week where we're going to continue with fractions.